Hello, welcome to another episode of SecurityFWD's Hacking with Friends, where we don't actually hack. I don't know if I have any friends. And we're studying for the CISSP exam from the ISC² folks. I'm Mike Buckby. I used to have my CISSP. I then lost it as I didn't keep up with my CPEs and didn't worry about it for a number of years. And now I'm back studying for it. And together we will achieve the goal of passing the CISSP and adding that to our LinkedIn resumes. I don't really use LinkedIn. Anyway, let's go ahead and get started today. Also, I was out last week. I don't know if anyone actually noticed or cared, but I had my second shot and was feverish and in no condition to get on here and study anything. So, all right, let's get going here. Today we're doing two different sets of questions. As always, we're doing this from Quizlet. So this is official ISC² material that you can find yourself on Quizlet. And we're going to be doing two sets of stuff. This is actually from the CISSP, I think, but it's a review of cryptography, different aspects and concepts related to that, and then a review of network protocols. Let's get started with the with cryptography. Hey, David. Oh, thanks. People are being very nice. All right. Oh, as always, we're also going to be giving away a nice. I don't have it here because I do. The nice Yeti mug, 8-bit one of these, so it should be on the way. But yeah, it actually says Varonis on it, who's sponsoring this, but I put stickers on it. I don't even see my stickers. Star Wars coffee, paste Darth Vader. You can put whatever you want on it. So whoever does the best, by our very loose standards of best, we'll also be getting a Yeti mug. I won't be drinking out of it because it keeps the coffee too hot, but they're still nice. All right, here we go. Two different but mathematically related keys are used, where one key is used to encrypt and another is used to decrypt. Like always, try to get people to answer in chat, try to have a discussion. A lot of times, a lot of what is on the test is teasing out the nuance between two different things. And then they just ask you a question and you have to just keep dialing down into that nuance. So in this case, 8-bits answered, I think, correctly to me, which is asymmetric. So let's go ahead and see if that's the case. And I lost my cursor. Asymmetric. Awesome. Yeah. So asymmetric is anytime you have two keys and the public one is used to encrypt and then the private one is used to decrypt. So that's the basis of tremendous amounts of networking and encryption infrastructure we all use every day on the internet. All right. Encrypt decrypt requests are processed in queues. Hey. Joseph also answered asymmetric. Very good. All right. Asynchronous. This is one of those nuanced things. Certainly you could have synchronous queues as well, but that's how they're describing it. To my mind, I always think of synchronous as happening in sequence. So 1, 2, 3, 4, where asynchronous could happen out of order, and you have multiple queues where it can pluck from any order from the different queues. So if you imagine like 4 shoots, and maybe it takes from the first one, and it takes from the third one, then it takes from the second one. All right. An entity trusted by one or more users as an authority in a network that issues, revokes, and manages digital certificates. So I'll give you a hint. This is normally abbreviated as CA, not California. Though certainly there are some in California. So, an organization. It is an organization. Here, I'm going to move this restream chat so it doesn't look like I'm looking at the ground so much. All right, this is certificate authority. Yeah, so these are neat. I like neat to me, a person who's interested in this stuff. But if you want to read something really interesting, go look at like the Let's Encrypt folks when they decided to become a certificate authority and all the stuff they did. You have to like do these things that sound almost like magic enchantments or, you know, summoning rituals where like you have to have 5 people and they do like a signing key for the root and stuff. Interesting to start your own certificate authority. All right. The study of techniques in attempting to defeat cryptographic techniques and more generally information security services. So this is one of those like nuanced multiple things. So they're asking for the general study of this and not the specifics of the implementation, which is something that comes up a lot. We always talk about like the management mindset or sort of the abstract mindset of this. So I think this is cryptanalysis. Yeah, cryptanalysis. All right. So the study is cryptanalysis, and then this is the science that deals with these, which I believe is cryptology. So let's try that. Cryptology. All right. Represents the entire cryptographic operation. This includes the algorithm, the key, and key management functions. Entire cryptographic operation. Encryption and decryption? This is probably some term I'm not thinking of. Anyone else have ideas? Entire cryptographic operation. Yeah, this is 8-bit saying this is a lot of crypto stuff. This is the cryptography section in Quizlet of actually the CCSP. But I looked through it and the concepts are the same, and it's a little different view into it that I think is helpful. At least it's helpful to me in refreshing on this stuff. Crypto system. Yeah. I think this is one of those hard things. Like a lot of the cryptography stuff is interesting and from like an intellectual standpoint, but it is mostly not practical. Like even, I don't know how much people are into the developer stuff, but there's like a mantra in the developer world of like, don't roll your own crypto. Like you are going to mess it up. Like you could read this algorithm and then try to implement it yourself. But that is such a fraught endeavor where most of the people that try to do that mess it up. And even the people like, you know, look at something like OpenSSL, which has had like a lot of weird issues. OpenSSL is a library that's used in almost every different networking utility, like anything that has to interact with SSL. And it's this huge, sprawling, massive code that, did not have enough contributors and people are trying to add stuff to it. And, even experts, have issues with this stuff. So I think for those reasons, it's hard to learn this stuff. But it is good to know, like, how the different things function. So, all right. They made this tiny type for some reason. The reverse process from encryption. Yeah. Pico CTF crypto section. I haven't tried that CTF. And Andre's saying most developers will bring in people who specialize in cryptography. Yeah. Yeah, this is Decrypt. Andre's absolutely right. Like, it is such a specialist thing. So, and I think the real danger with it is it's very easy to shoot yourself in the foot and make it so your cryptography and your cryptographic system is worthless and not realize it. So, all right, an electronic document contains the name of the organization, individual, business address, digital signature of the certificate, and authority. I think this is the certificate signing request. Digital certificate, no. All right, so I was thinking, again, maybe too practically. So the CSR, the certificate signing request, is what you give to a CA when you're trying to get an SSL TLS certificate. This is just a digital certificate. Okay. And this is a mistake I was making, which is, again, thinking too practically and not like abstract enough. All right, we'll try the next one. All right. Provide authentication of a sender and integrity of a sender's message. I think this is digital signature or like encrypted signature. Signed signature? Digital signature. Okay. All right. The process of converting the message from its plain text to ciphertext. So that would be encryption. That one's an easy one. All right. One-way mathematical operation that reduces a message or data file into a smaller fixed length output or hash value. I'm going to go with hash function. Hey, hash function. My favorite, hash functions. Does anyone else have favorite algorithms? I like hash functions. I don't know if that's an algorithm. It's just a function. So, all right. A non-secret binary vector used as the initializing input algorithm for the encryption of a plain text block sequence to increase security by introducing additional cryptographic variants into synchronized cryptographic equipment. I think we did this before, and I said SALT. But this might be initialization vector. Question too big. Yeah. Non-secret binary. Initialization vector. Yeah. Which is usually a SALT. And what that is that, like, imagine you're, and this is a very practical thing. Imagine you are implementing an authentication system for a website. So just like you want people to put in their email address, and then you want to put in their password, and then you want to store that password. Well, if you just run a hash function over that, it turns out something that's very predictable. And if someone was to get a hold of that database, they would be able to then say, like, run MD5 or SHA-1, SHA-256, these different hash functions, and guess what a lot of these are. And as soon as they know it, they could then know all of them. They could see, like, oh, this is using MD5, so therefore all of these are MD5. And 8-bit saying hash then salt, but I think it's actually the other way, is typically you take the salt and you add it to the plain text and then you hash it, because that obscures what was used for the hash function. So imagine you had password like one sad puppy, number one sad puppy, and then you add a salt to it that's based on some other outside mechanism and that isn't stored in the database. And so by combining those and then hashing what that password concatenating to the salt, hashing that result gives you something that is not so easily discovered. And that's what this initialization vector is that it's not just the hash, but it's a hash plus like juking back and forth to try to like throw off, someone if they were to be able to look at the plain text and the cryptographic variant of it. Okay. The input that controls the operation of the cryptographic algorithm determines the behavior of the algorithm and permits the reliable encryption and decryption of the message. I want to say like configuration, the key, input that controls the operation. That seems like a lot to put on the key in this, because there's a lot of other things you could do, especially when you get into the more complicated cryptographic algorithms where there's things beyond just like key or key size, but actually like number of turns and things in it and stuff. So, all right. When different encryption keys generate the same ciphertext from the same plain text message. Different encryption keys. I think it's collision. That's my guess. Key clustering. Different encryption keys generate the same ciphertext. Interesting. All right. Did not know that one. All right. Key clustering. represents the total number of possible values of keys in a cryptographic algorithm or other security measures such as a password. The total number of possible values. Maximum state, maximum key space, cryptospace, key space. Total number of possible values of keys in a cryptograph. I guess, it makes sense in terms of keys of a cryptographic algorithm. Keys are part of cryptographic systems. But it doesn't make so much sense to me as a password. So, all right. A security service by which evidence is maintained so that the sender and recipient of data cannot deny having participated in the communication. Non-repudiation? Security service by which evidence is maintained. Digital lockers? I don't know. Non-repudiation. All right. Yeah, non-repudiation. I know we talked about this before. Like the big one of these that's actually in the wild that's practical is that there's a service with email called DKIM, which is really an anti-spam service. But oftentimes services, much like Gmail, they rotate their keys. So every 3 months, there's a different public key that they use. And if you look at, sometimes there'll be like an email leak. You can look in that email leak and see the headers in the email and see what the DKIM signature is. Compare that to the public key that was used at the time that the email was sent and have a very strong evidential case that yes, this was actually sent by this person at that time. Because otherwise it'd be so easy to just say, yeah, I got an email from XYZ politician saying like, hey, I'll take the bribe money for the Bayou, construction. So like an actual practical case of this that you can go out and look at. All right. The message in its natural format. Natural format, I would say plain text, or clear text. One tricky thing that's caught us before studying for this is that in cryptographic systems, plain text refers to anything that's unencrypted. So even if it's an image or something that is encrypted, it still starts off as plain text, whatever the actual file type, when talking abstractly about all the cryptographic stuff. Yeah, APIT said they're going to look into some of the stuff. I mean, there's been actual politicians and people caught out, like maybe even like the Sony hack stuff through that. So, all right, perform certificate registration services on behalf of a CA, a single purpose server responsible for the accuracy of the information contained in a certificate request. I think it's a signing server or signature, digital registration authority, the RA. Sorry, I bet that looked weird. I was just taking a sip of my coffee, but my whole head was off the screen. I do a bad job of keeping my head in the little box, but all right. Registration authority, just like an RA at your college. So, all right. Each encryption or decryption request is performed immediately. I'm going to guess they mean synchronous, and because we had the thing about asynchronous before, though again, this is not exactly right to my way of thinking, because there's no reason asynchronous couldn't be immediate as well. It's just, to my mind, it's more an ordering than an immediacy, but all right. The process of reordering the plain text to hide the message. I guess it's scrambling or transposition. All right. Represents the time and effort required to break protective measure. Mean time to failure, failure rate, brute force rate, work factor. I should study more. Obfuscation. Obfuscation's interesting. Like that seems like it might be right. But I think that would be, I guess if it was only, I'm trying to think. I guess if you were taking a document and you just did, well, maybe transposition is the form of obfuscation. Work factor. Okay. All right. So that was all the crypto stuff. And I think that drove everybody off but 8-bit. So, it's nice we're still hanging out. And I guess I didn't think about it, but, after now that I've had my second shot in a couple weeks, everyone can just come over to the house and, we'll hang out in the backyard. That's it. Refresher on encoding, hashing, and encryption. Cody and I did a live stream on it. Oh, Mike, thanks for throwing that in. Well, there's the live stream. That's cool. All right. So we did encryption. Now we're jumping over to network security protocols, network security, which is almost all security now. So here we go. All right. Is used at the media access control layer to provide for direct communication between two devices within the same LAN segment. I think this is ARP, Address Resolution Protocol. ARP. All right. I know cryptography better than networking, so this may be a rough set of 50 questions, but we'll see how we do. All right. The most essential representation of the data, 0 or 1 at layer 1 of the OSI interconnection model. Binary is 0 or 1. I think that's easy. Layer 1 is, I thought layer 1 was physical, which doesn't make sense to me. I need to review my layers. All right, let's see. OSI layers. And let's look at images. Oh. From our friends at Imperva. All right, layer 1 is physical. We're just going to keep this tab up. Yeah, layer 1 is physical. That's right. Transmits raw bit stream over the physical medium. Okay. I guess there's physical, then there's physical. Like I was thinking of, is this copper or is this fiber? Is this, that type of physical? But if they're talking the raw bit stream, they're talking the signal at the physical layer. All right. You know what? Let's just do a quick review of the layers because I think that'll probably help us with all these questions. All right, 1, physical layer, raw bit stream. Data link layer defines the format of the data on the network. Okay, so like Ethernet frames. Network layer decides which physical path the data will take. All right, transport layer transmits data using transmission protocols including TCP and UDP. Okay, that makes sense. Session layer maintains connections and is responsible for controlling ports and sessions. Okay. Presentation layer ensures the data is in a usable format and is where data encryption occurs. Okay. Application, human interaction layer where applications can access the network services. Okay. Hidden layer 8. The cow level in Diablo. All right. Let's try this networking stuff now that we're all experts at OSI layers. All right. So that was physical. Oh, it says bit. Most essential representation of data. Oh, okay. So I said binary, which would be, I guess, maybe the protocol. All right. Okay, Bluetooth wireless technology is an open standard for short range. That's not helpful. Oh, this is just describing Bluetooth. Oh, okay. All right, layer 2, which is the data link layer. Sounds like Richard Linklater, but that's not correct. Data link layer. Devices that filter traffic between segments based on media access control address. A switch? Or hub? Bridges. Filter traffic. I think what's throwing me is the filter part. Because I didn't. All right, now I want to find out the difference between them. difference between bridge and switch. Oh. All right. A LinkedIn user, and I apologize. We're using Restream for the chat, so it has all the services and it doesn't have your name, but you put a really great thing in here, which is sort of like a mnemonic for all the layers. Please, physical do, data not, network throw, transport sausage, session pizza, presentation away, application knowing OSI like the back of your hand is 100% required for networking. Yeah. Difference between bridge and switch. All right. Bridge is a device that connects two LANs and controls data. Yeah, the user eats the pizza. And it's actually lunchtime here. I'm really getting hungry. All right, a bridge is a device that connects two LANs and controls data flow between them. A switch is a networking device that learns which machine is connected to its port by the device's IP address. And I guess this is what's throwing me off about this, is that this filtering traffic, I would have thought that it just makes it like one network. It just dumps everything back and forth as a bridge. All right. A radio network distributed over LAN areas called cells. Cellular network. Every call's data is encoded with a unique key, then the calls are all transmitted at once. Batching, code division, multiple access, CDMA. Every call's data is encoded with a unique key, then the calls are... All right. Multiplex connected devices into one signal to be transmitted on a network. Concentrators? I'm sorry if I'm just skipping through these. I don't have a lot of color to add to these, as it's something that I'm not so familiar with. All right. Is a large distributed system of servers deployed in multiple data centers across the internet. Load balanced? Content CDN. This is frustrating. I don't know. Like I've done a lot of like work like this, but I wouldn't have called that a CDN. Large distributed system of servers deployed in multiple data. All right. Yeah, I hate how they ask the questions. And these aren't even quite questions. I mean, this isn't the exact format of the test, but it's confusing that these are sort of flashcards. So they're just trying to like bump the knowledge in your head, which I think is probably better for studying than like a multiple choice, which is why I'm doing this. All right, saying Akamai is the best example of a known CDN. You're leaving out Cloudflare, you're leaving out CloudFront. You know, there's a lot of CDNs. All right. Whenever a service is requested that is associated with well-known or registered ports, these services will respond with a dynamic port. It's requested with a well-known, dynamic or private ports. Yeah, these are just unassigned. So if you want to do something fun with ports, look up port knocking for sounds like something bad, but it's not. It's really just like a signature system for like getting SSH in to systems. Port knocking. All right. A lightweight encapsulation protocol and lacks the reliable data transport of the TCP layer. I know this one. UDP. It wasn't UDP. It was fiber channel over Ethernet. A lightweight encapsulation protocol and lacks the reliable data transport of the TCP layer. It says layer. But let's see, the transport layer. So it's at the network layer, it's physical path. This is fiber channel over Ethernet. Okay. All right. Devices that enforce administrative security policies by filtering incoming traffic based on a set of rules. I'm going to say firewall. Firewalls, yeah. I'm going to blame myself a bit. All right. Data represented at layer 2 of the OSI. This is data link layer. Frame. Oh, I'm going too quick. So this is saying the data, not what the layer is. So I already messed it up. But data represented at layer 2 of the OSI interconnection model. All right. And so the format of the data on the network. So I was saying like frames, like Ethernet frames earlier when we talked about this. And that's what this is. Yet I still messed it up for bad test taking skills. All right. Each call is transformed into digital data that is given a channel and a time slot. I'm thinking this is like multiplexed global system for mobile. It's saying call, and I keep thinking this means like API call and not like, hey, pick up a phone and call your mom. And these are the different cellular protocols. So, all right. Provides a means to send error messages and a way to probe the network to determine network availability. I believe this is what is ping is based on, which is ICMP. Yeah, ICMP. Send error messages and we're going to probe the network. All right. Check the time. All right. Used to manage multicasting groups that are a set of hosts anywhere on a network that is listening for a transmission. Multicast? Internet Group Management Protocol. Our LinkedIn user said ICMP. They got it right. So, user managing IGMP. So wide area networking protocol that operates at both layer 2 and 3 and does label switching. BGP? Oh, I guess it was in the title. Multi-protocol label switching. Though MPLS sounds like a disease. So sad I got diagnosed with MPLS. Multi-protocol layers. Label switching. All right. Physical layer. Layer 1. And then the data format on layer 1 is bits. Okay, data link layer is layer 2, and the data format on layer 2 is frames. Network layer. That is layer 3. Layer 3, which physical path will layer take. Does anyone know what the data representation is on the network layer? It's layer 3. All right, transport layer, layer 4. I think this is cheating because they're going in order. Session layer is layer 5. Okay, usually IP at the transport layer. Session layer contains connections and ports. All right, so you'd need TCP. You need like transmits data using transports. So transport layer is TCP and UDP. Network layer is IP. Oh, okay. This is getting an IP address and then TCP and UDP at the transport layer. All right, session layer. Presentation layer, 6. Application layer is 7. Okay. All right, the objective of NFV, which I don't know what that is to decouple functions such as firewall management, intrusion detection, network address translation, or name service resolution away from specific hardware implementations into software solutions. NFV? Software-defined routing, but network function virtualization. Okay. Is the dominant protocol that operates at the OSI interconnection, OSI network level 3. All right, that's what we're talking about. IP is responsible for addressing packets so that they can be transmitted from the source to the destination host. All right, 3 is IP. Is a modernization of IPv4 that includes a much larger address field, IPv6. An interior gateway routing protocol developed for IP networks based on the shortest path first or link state algorithm. IGP? Open shortest path first. All right. Representation of data at layer 3. This would be IP, which is the transport layer. It's a packet. All right, I messed something up. All right, let's see. 3, network decides which physical path. It's a packet. All right, so we got bit frame packet. Okay. And then, okay. Slowly it's coming together. Man, 8-bit, you're killing it today. All right, a technique called packet loss concealment is used in voice to mask the effect of dropped packets. Packet loss. I don't know quite why that was the answer, but I understand that. So, all right. Provides a standard method for transporting multi-protocol datagrams over point-to-point links. Transporting multi-protocol encapsulation? Point-to-point protocol, PPP. That would certainly be point-to-point. An extension to NAT, network address translation, to translate all addresses to one routable IP address and translate the source port number in the packet to a unique value. Port forwarding? Port address translation. Okay. Exceeds maximum packet size and causes receiving systems to fail. Ping of death. We just get t-shirts made up that say ping of death. All right. Network mapping technique to detect if host replies to a ping, then the attacker knows that a host exists at that address. Ping scanning. All right. Ports 1024 to 49151. Non-system applications. These are reserved, registered ports. Data representation at layer 4 of the OSI interconnection model. All right, so 4 is transport layer, TCP and UDP, but it's the representation, data representation. So we did bit, frame, packet, bit, frame, packet, segment? Segment. Man, 8-bit's killing it today. All right. Is designed to manage multimedia connections. Session initiation protocol. ICMP echo request sent to the network broadcast address of a spoofed victim, causing all nodes to respond to the victim with an echo reply. It's ultimate ping of death. Smurf. Separates network systems into 3 components: raw data, how the data is sent, and what purpose the data serves. This involves a focus on data, control, and application management functions. I started talking when I clicked on software-defined networks. Okay. Is an extension of the SDN practice to connect entities spread across the internet to support WAN architecture, especially related to cloud migration. Software-defined wide area. Okay. Operate at layer 2. A switch establishes a collision domain per port. All right. So, layer 2, data link layer. Let's go back to our bridge versus switch. Which machine is connected to its port by using the device's IP address? This is what I get for spending years as a web developer instead of a network sysadmin. Switches. All right. Provides connection-oriented data management and reliable data transfer. I think this is TCP. Yeah, transmission control. Exploits the reassembly of fragmented IP packets in the fragment offset field that indicates the starting position or offset of the data contained in a fragmented packet relative to the data of the original unfragmented. Exploits the reassembly? Teardrop attack. Okay. Layering model structured into 4 layers. Network, internet, transport, host to host. Layering model. TCP model. All right, the user datagram protocol, UDP, provides connectionless data transfer without error detection and correction. Oh, okay. Thanks for telling me that. Allow network administrators to use switches to create software-based LAN segments that can be defined based on factors other than physical location. Network administrators to use switches to create software-based LAN segments that can be defined based on factors other than physical location. VLANs. All right. Technology that allows you to make voice calls using a broadband, so VoIP. Okay. Ports 0 to 1023, related to common protocols. Well-known ports. What a crazy name. Never use the default VLAN. That'll be 8-bits t-shirt in addition to Panda. All right, a whitelist is a list of email addresses and enters known as good. A blacklist is bad. Whitelisting, blacklisting. Primarily associated with computer networking, Wi-Fi. Okay, this is Wi-Fi. Okay. Wireless broadband is WiMAX. Some of these aren't done as questions. Okay. Well, I think that's it for today. Just want to thank everyone for joining. We're trying to figure out if there's anything more we can do to make this more interactive. I haven't had time to actually try to make something else. We had at one point had used one of the servers, I think it was Cahoots. These were easy but fun for you, 8-bit. Like to do more of a quiz or something. I think we still want to try that, but just haven't been able to get it together. We'll keep working at it. And thank you everyone for joining today. And I think that's it. Have a good week. Or actually, I'm going to phrase that. Have a good weekend. All right. Bye.